We are in a room which is HPLC room. We've got 6 HPLCs. In the main lab, we've got 2 ion chromatographs, and in the other room, we've got 2 LCMS. They are chromatographs. Chromatography means science about separation. Students bring samples, and it is a mixture of compounds, and we separate them to find out what is inside, and we try to quantify what is inside. HPLCs are used across the whole School of Water and Energy. We've got plant science students and their routine analysis like sugars, organic acids, phenolics. We've got water students, and their routine analysis are natural organic matter and volatile fatty acids. For energy students, we are doing fermentation products. For mycology, we are doing mycotoxins. When it's MSc season, as we call it, it's busy. Yes, all 6 are running, and there is always queue. A part of this we are using for external projects quite a lot, these machines, and researchers, and we've got a lot of method developments because chromatography, liquid chromatography, is like going to the dressmaker. You can use old dress, you can do new amendments, or you can create something new. For water is a quality of water, and it's like pesticides, which is very important now, and monitoring very carefully. Energy students are trying to find out how to change waste into something which is very useful, like sugars. What is maybe unique that we've got nearly every detector you can imagine, because these machines are not different because they are in a different position, because they've got different detectors. They've got different system of pumping, and what is maybe unique, the students get trained to them. They are not only watching, they can get training, and they can do their analysis themselves later. HPLC means high performance liquid chromatography. The difference between GC and HPLC is that our mobile phase is a liquid, and all separation is happening on the stationary phase, which looks like this. And every liquid chromatograph has got the same features. First, you can see solvent compartment, and it is an organic solvent mixed with water, or sometimes only organic compartment. It is degassed with a special instrument. Then it's pumped through the whole system. There is a autosampler and injector, which makes us injecting sample into the stream of our solvent. Then mixture of solvent and our sample is carried into the column. On the column, the whole separation is happening, and separated mixture is going to the detector, and detector amplifies signal and gives our signal proportional to the amount of compound what is in the sample. And the last feature is a computer which controls the whole system and gives us information what it is inside. Here we can see our machine in action. The sample is mixture of organic acids, which one of our energy students is trying to find. And we can see peak from acetic acid and 3 peaks from succinic acid and lactic acid. In the other room, we have 2 LCMS. LCMS is a joining power of liquid chromatograph, which means LC, and MS, which stands for mass spectrometer. And it is basically the same technique what you can see in our HPLC room, just better detector, which is a very selective, and you can trace ions which are in a very low concentration. We've got two different mass spectrometer detectors. One is just quadrupole, and the other detector is QTOF, which measures time of flights. LCMS work very similar to HPLC. We've got exactly the same solvent compartment. Solvents are the gas, are pumped through the whole system. Sample is injected into the stream of our mobile phase. Sample is separated on the chromatographic column, and now it goes to the detector, and it is a difference. In the detector, it is turned into the gas, and detector creates ions, and they are selected by the mass to charge ratio. Recently, we can see a big interest in using our LCMS. It is because detectors are very selective, and we can trace down compounds to ppb or even ppt level. It is used by whole school as well. For plant science, we're monitoring plant hormones. For waters, we are monitoring pesticides. For mycology, we are monitoring mycotoxins. This machine is ion chromatograph, and we've got two ion chromatographs here. It is just a liquid chromatograph. The difference is only that we are using it for separation ions, mainly in the water, and it's used by water science students, and it is used for monitoring ions, common ions like chloride, fluoride, or sulfide, or calcium, or sometimes it's used for monitoring disinfection bioproducts like chlorate, chlorides. It is easy and relatively cheap way to monitor our ions to the very low levels in drinking water or in wastewater. We had quite a few projects from different countries. As you can see, it works as other liquid chromatograph. We've got mobile phase, which is called eluent in this case. We've got pump, which is pumping our eluent through the whole system. We've got autosampler, and injector, which injects our sample in the stream of our eluent. We've got detector, which is here conductivity detector, and we've got computer with a software which you can monitor what is coming out. Majority of our samples are just wastewater or water samples, and it can be even tap water, and you can monitor chloride level. As you know, we are using a lot of chloride for disinfection, so you can monitor if it is not too high.